Hi, everybody. Welcome to TGCS. My name is Tim Gallagher, and today we are going to be discussing AP Computer Science A, topic 4.13, implementing 2D array algorithms. And in this second video, we're going to continue to develop code for standard and original algorithms for our 2D arrays and determine the results of these algorithms. For this video, we're going to focus on these three algorithms. First, determine if all elements of a 2D array have a particular property. Next, determine the number of elements of a 2D array that have a particular property. And finally, access all consecutive pairs of elements. So remember, before we code any of these algorithms, it's very important to figure out what we need to do, what our constraints might be, what results are going to be produced. Do we have to do a row major order or a column major order? What is our goal? What type of results do we want? What types of values we have in the 2D array? And then do we need to traverse the entire 2D array or maybe just a column or a row? And could we halt early before traversing everything? All of that depends on how we develop our algorithm. So let's start with implementing this method. We want to determine if all of the strings in a 2D array called words are longer than the parameter length. If this method returns true, they are all longer than length. Otherwise, it's going to return false. But again, let's discuss the algorithm first. What are the steps that we'll take to evaluate these strings? Well, first we'll need to traverse the 2D array. And in this situation, order doesn't matter. We could do row major or column major order. Next, we'll need to compare the length of each string to the parameter length. Well, what are we looking for? Well, if the string is longer than length, then we should keep evaluating the other strings. There's nothing to do if we haven't found one that does not meet our criteria. However, if the string is not longer than length, that's a situation we have to deal with. All it takes is one string to make the all words longer than no longer true. We should immediately return false in that situation. We don't even have to check the rest of the strings. Even if the rest of the strings are long enough, we already found one that isn't. So there's no way that this method can return true. And then finally, if we traverse the entire 2D array without ever returning false, well, then that must mean that all of our strings are longer than length. So now we can return true. That's our algorithm. So can we change this into code? Feel free to pause here if you want to take a crack at this first before we look at the implementation together. All set? Okay, here we go. One strategy for implementing an algorithm is to change the steps into comments so that this can help us direct how we can write our code. So here you see our algorithm printed out in comments. Now, what do we need to do? First, we'll need to traverse the 2D array. We'll use enhanced for loops in this situation because this works well with our row major order traversal that we can use. Next, we'll check to see when current.length is not greater than the length parameter. There's a few ways we could do this, but here we used greater than, and then I put a not symbol outside of our Boolean expression. If that is true, then we're going to immediately return false. If it's true that there's a word whose length is not longer than length, we're going to return false. Finally, after we finish all the way through our loops, well, that indicates that we never found a word that was not long enough, so we can now return true. And that's our algorithm that we implemented to check if all the elements of our 2D array had a specific property. In this case, we verified that all of our strings were at least a certain length. Let's try another one. Here, let's implement an algorithm that counts the number of elements in our 2D array that have a particular property. This method accepts a string of length 1 called letter and a 2D array of strings called words, and we want to return the number of strings in words that begin with the string letter. So again, let's discuss the steps of our algorithms first to determine how we're going to do this, then we'll implement the algorithm in code. So we're going to need to traverse the 2D array. Again, order doesn't matter. As we traverse, we're going to check each current string to see if it begins with letter. If it does begin with letter, we're going to need a counter. So let's go back to the top and declare and initialize a counter in our algorithm. Now, if we find a string that does begin with that letter, we're going to increment our counter. And finally, we're going to return the number of words that we found by returning our counter variable after the entire loops have been completed. Pause here if you want to try implementing this on your own, and then we'll look at it together. Okay, great. Let's change these steps to Java comments again. All right, here we go. And now let's fill in the code that corresponds to these comments. First, we're going to start by declaring and initializing a counter to 0. We'll traverse our 2D arrays, again using enhanced for loops. We'll check to see if our current string begins with letter. We'll do this by using the substring method and the parameters 0, 1 to extract the first letter of current, and then we'll use the dot equals method to compare it to the letter parameter. If this is true, go ahead and increment our counter. Finally, after the loops have been completed, we'll return the total number of words that we found by returning counter. And that's our algorithm that we determined the number of elements in our 2D array that had a particular property. And in this case, that they be the ones that began with a certain letter. Finally, let's implement an algorithm that involves accessing consecutive pairs of elements in our 2D array. So this method accepts a 2D array of integers called values and a column number. And we want to determine if the consecutive values in a particular column are increasing as we traverse the rows from row 0 all the way to the last row. Again, let's discuss the steps of our algorithm first, and then we'll implement it. So we know we're going to need to traverse a given column, so we'll increment through each row of the column parameter. We're going to verify that the column, the value of the column, is less than the one in the next row. We'll do this by comparing consecutive elements within the same column, which have adjacent row numbers. If it is, well then go to the value in the next row, same column, and check that value against the one in the next row. And we simply do this over and over again and do nothing and continue with the iteration of our loops until we get to the end of our column. But if we ever find a value that is not less than the one after it, well, then we're going to need to return false immediately because the values in our column are not increasing. Just finding one set of consecutive values that does not meet our criteria, which is increasing values, this will cause the entire column to not be increasing. Therefore, we don't even need to check for the rest of the values in the column. All right. If we've got to the end of this and we never returned false, we're going to go ahead and return true because we traversed the entire column without ever finding values that were not increasing. So if you want to try implementing this, again, one more time, pause here, try implementing this on your own, and we'll get back to the code in a second. All right, let's put these steps as comments and write our code. So just like this, now first we'll have a single loop to traverse the rows of a given column. Notice I'm looping through using the R variable starting at 0, and I'm going up to values.length, which is the number of rows in my 2D array. Well, how do we compare a value to a value in the next row of the same column? We're going to say if values R column is less than values R plus 1 column. This compares the value in a column to the value in the next row of the same column. So using R and R plus 1 gives us consecutive values when we use the same column variable. And we want to return false if this is not true. So really, we're going to need to add a exclamation point here before our Boolean expression, because we want to return true or return false if this is not a true situation. Then after the loop is completed, we're going to return true if we're still here, because that means we never found values that were not increasing. Okay, we still have one problem here though. We still have to fix something. Can you spot what it is we have to fix? Yeah, right here with our current loop going up to but not including values.length, having values r plus 1, that's going to throw us out of bounds past the last row. So we'll need to add values.length minus 1 to prevent our loop from going out of bounds. That's an important detail to remember when writing an algorithm that involves evaluating consecutive elements of a 2D array. And that's our completed algorithm that involves comparing all the consecutive elements for a given column. So today we developed code for standard and original algorithms that involve 2D arrays and determine the results of these algorithms. Specifically, we determined if all the elements of an array had a specific property. We counted the number of elements in our array that had a specific property, and we developed an algorithm that compared consecutive elements of a 2D array. We'll finish up our look at 2D array algorithms in our next video. That's it for now. Thanks so much for joining us here today. Don't forget to hit that like button, subscribe to this channel, and we'll see you next time. Take care.